After.
Well, it would be great that by now.
Yeah. So actually, I've been in security for 8 years now. I work for Security Innovation. We're based out of Boston, and I'm a security trainer, application security trainer. And when I come to security conferences and talk, I feel like I am speaking to the choir. You're obviously interested in security. That's why you're here. So actually, this year I've been going to just developer conferences, speaking to developers who never get to hear about security. So it's been a really great experience. But this is my first security conference this year. And if I ever sound angry or it's not directed towards you because you are my choir, but security is a frustrating world right now. But I want to talk about how we add security to an agile environment, specifically continuous integration or continuous deployment. So just out of curiosity, how many of you are agile developers? It's one. Good. Good. Well, this should all be new then, I guess. So it's interesting that it says here software development is speeding up because we're doing such a great job of it. We thought we'd do it even faster. And it's frustrating because we weren't doing it well to begin with, and now it's becoming more common, not in this room, but it's becoming more common to start doing continuous integration, continuous deployment, which I think is really cool. And I've taught application security to teams, and it's so common. They say, well, we're too busy. We don't have time for security. And my answer is, oh, nay, you absolutely do. So for the next 23 minutes or so, I'm going to talk to you about how do we add that? How do we get security into this fast-paced culture? So is continuous integration, continuous deployment, is it hostile to security? Well, the answer is no, because if it was, then this would be even shorter of a talk. But it isn't. There's plenty of things we can do to help us try to get rid of all these vulnerabilities that are riddling our code. But continuous integration, continuous deployment, it boils down to these 4 tenets. We want to make it fast, we want to be early, we want to be often, and we want to be responsive. Which is interesting because Grady Booch talked about that in 1991 in his very famous, very popular object-oriented design book. It's one of the first books I read after I graduated with my computer science degree. But it's kind of like, oh, now we're just kind of relearning that this is an interesting way and very successful way to do software development. So, but how do we add security into this without bogging ourselves down? And that's such a management way of thinking, because management's always like, go, 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 go. And as a security guy, we're stereotypically saying, stop, stop, stop. So how do we add security in without freaking out management? As part of continuous integration, continuous deployment, we have some things that they have to have. They want to be able to check in frequently. Yeah, that's just good software development. Don't check in broken code. That's just good software development. Don't check in untested code. You see where I'm going with this. This is all just good software development practices. It's not unique to continuous integration and continuous deployment, but a lot of times management likes to think that they're unique, no one does it like they do, all their people are the best and brightest. Well, okay, let's get to the security part. Where does security fit in? And as a security guy, I want to say we need to put it everywhere. Now, I understand though, we can't slow ourselves down. We have to worry about performance issues. We can't have every other line of code doing some kind of security function that's going to make our users hate us. So I'm going to go through the 4 tenets of continuous integration, continuous deployment, and talk about how we add security into all of those. So let's start with fast. We got to make sure security doesn't hold back integration. So one of the things we can do that's widely available is we can run static analysis tools on developers' machines while they're writing code. So we're not slowing them down, yet those static analysis tools are finding, easily or common problems that we're seeing in code. It's going to find, oh, you just wrote a SQL injection vulnerability. Oh, you just wrote a insecure direct object reference. So it's going to find those things before the developers are even checking in their code. It's going to be happening in real time. It's running on their machine as they're writing code. So it's going to hopefully not annoy them too much. Now, the issue with static code analysis tools is, one, you're going to have false positives and things like that. So there is going to be probably some setup, some tuning that has to go on beforehand. And then also, it's common to have a false sense of security. Teams say, oh, well, we ran our code through a static analysis tool, a Fortify, a ConVerge. We found everything. We fixed it. We're 100% secure. No, you're not. There's no such thing as 100% security. This is just one of the layers of defense we're going to be using. So, again, this is, we're trying to keep it fast. It's important to have, but it's just one layer of defense. We can do automated scanning when we're performing integration or doing our test deployments. We're using tools like a Nessus or something like that, where, again, it's looking for common security vulnerabilities. It's looking to see if we have host hardening issues. But, again, it's automated. This is taking place while we're doing all the other stuff we're already doing. We're not slowing anyone down. Now, of course, when it finds problems, yeah, we got to take care of them. But that shouldn't be thought of as it's slowing us down. It's like, we found a bug in our code, we're going to fix it. There's got to be time for that. And then finally, the last one is penetration testing. Now, my team likes to say, you can either pay for penetration testing or have it done to you. And I prefer paying for it. Because if you have it done to you, bad things usually happen after the vulnerabilities are found. They don't ask politely as they're stealing your data. So, unfortunately, penetration testing, it does cost money. And good pen testers aren't cheap. I mean, that's why they're in such demand right now, is it's a skill set that just isn't widely available. So depending on the criticality of the data that you're processing, the sensitivity level, this may be something you do, is have penetration done at a certain period of time. Next is early. How can we add security while we're focused on getting things done as early as possible? And it really boils down to start thinking about security when we're in the requirements phase or the user stories phase. Start thinking about abuser stories. Start thinking about how do the bad guys look at our applications. And it does take a little time to learn how to do that, yet we do it in the real world all the time. We just don't realize it. Here in Detroit, you're walking down a city street, it's midnight, it's dark, and there's an alley. You think to yourself, I'm not walking down that alley because there's probably a mugger down there. That's thinking like a bad guy. Because you're thinking, oh, if I was a bad guy, I would hide down there waiting for someone to come and I would then mug them. We got to think like that when we're developing our applications too. What would you do as the bad guy with this piece of functionality? We can do that during the requirements phase. We can do that when we're developing abuser stories. What would the bad guys do to our application? The earlier we think about it, the better chance we're going to have to stop the bad guys from doing those things. We've already thought about most of the stuff they're going to try. And they're going to try all the easy stuff. We've front-loaded, our thought process. We've been thinking about it. We know all of the low-hanging fruit isn't there. We know we're not going to have any OWASP, top 10 vulnerabilities in our code because we've already been thinking about it. We've already been talking about it. We've already tested for it. So the earlier we think about security, it's just going to make the bad guy's job as difficult as possible. And that's what we want. Threat modeling is a big part of that. How many of you have actually performed a threat model on an application before? So, a few. Good. Good. Yeah, such an important piece of the security puzzle. Threat modeling is something we do during design time where, again, we start thinking like bad guys, looking at our design and saying, what would the bad guys do? And we do that by thinking about where are all our inputs coming from? What are our assets that the bad guys would want? What are the roles? What are the permission levels that are going to be using this application? And it's interesting when I'm teaching application security, in most of my secure coding classes, the first question I ask them in the morning is, what are the assets that your application needs to protect? And even as a group project, a group discussion, they never get all of them. If we don't know what all of our assets are, it's really hard to protect them. Now, one of the common ones that developers forget about is your log files. Your log files are an asset. Bad guys are always going to go after your log files because that's where the evidence of all their nasty stuff usually is. They forget that. The source code is an asset. Now, source code needs to be protected. Bad guys want access to the source code. Just ask a hacking team what it's like to have all your source code revealed. It's an asset. So during the threat modeling process, we're going to list all the assets. But we have to do it because this is, we're talking about fast still. We have to do this in as timely a manner, so it has to be scaled. Well, guess what? Threat modeling is all about scalability. What can we do in the time period that we have? So, and obviously it's going to be different with every project, but we have that ability with threat modeling. Last one on here is train the team so they can participate in meaningful security discussions. And as of right now, the PCI standards say that if you are handling credit card numbers, your developers must be trained in secure coding, in the language that they're using. So the training is important because it gives developers a vocabulary that they share so that they can actually have meaningful discussions in their team. What are the possible problems here? They'll know what the common attacks are. They'll know what insecure code looks like in the language they're using. So without the training, you're going to have a inconsistent understanding of security in your teams. And I teach a class called Security Fundamentals, and one of the first things I do is I do a quick 15-question it's a questionnaire. And I give the students, they have 15 statements, and they have to say, okay, either 1, I disagree with the statement, or 10, I totally agree with the statement, or somewhere in the middle. All of the questions are things like, statements are, do firewalls stop all attacks? Does TLS stop all attacks? Do you disagree? Do you totally agree? Or somewhere in the middle? And then you score it and you add up the total. So what I want to see is I want to see everyone in the class put, 1s. I totally disagree with all the statements. And that, of course, never happens. It's a bell curve. And everywhere I've been, you get a bell curve. You have a couple people that have a good understanding of security. You have 3 or 4 who have no understanding of security. And then everyone else is in the middle. And these are teams. So the training is so important to get everyone on the same page, have the same vocabulary, and at least a similar understanding of basic security fundamentals. And again, it's one of the great parts of threat modeling too is getting everyone on the same page. What are our assets? You do the threat modeling process, everyone on the team knows here are the assets. What are all the inputs coming from into the application? Well, we list them during the threat modeling process, so now everyone knows where the input's coming from. It's real easy to make an assumption and say, oh, well, the team knows where all the inputs are coming from. Well, yeah, collectively, everyone knows that, but individually, no, they don't. And assumptions is how the bad guys get us. One developer makes an assumption, another developer makes another assumption, now we've got a vulnerability. All right, the third tenet in continuous integration, continuous deployment is often. Everything happens all the time, so security's got to fit into this too. So one of the things is we can't break the build. We can't break the build. So we add security automation in every layer to help identify breaking builds. And that means if a security vulnerability is found, that's considered breaking the build. If somehow a SQL I've forgotten what that's called. SQL injection vulnerability is in there. Or cross-site scripting. That's considered breaking the build. It's got to be fixed before we can continue on. We want to make sure those don't start creeping in. So we want to make sure, specifically, we're not introducing vulnerabilities that have been previously fixed, previously reported. Now, one of the ways we do that is with our testing. This is all happening at the same time. We want to make sure if a security vulnerability is found once, we now have written a test for it so that we can find it again. And as a developer in a previous life, I don't know how many times I would get a bug report. Okay, there's a problem in my code. I find the bug, I fix it, send it back to testing, and then like 2 months later, I get a bug report that sounds really familiar. Well, I wrote the same bug just in a different part of the code. This is what happens quite often. If we have a bug, we write a test case for it, and now we're running it. Those things are less likely to happen. We're doing it often, and it's automated. And the last tenet is responsive. We want to be able to respond to our security threats quickly. And one of those just means we understand what attacks look like. That falls back to training. We have to make sure our developers are trained in secure coding. We have to make sure our testers, if they're going to be doing security training, have some training. There's QA is very different than security testing. QA is looking for functional problems, very important. But our security vulnerabilities look very different than our functional bugs. I remember when the first language I was writing code in was C++, and I wrote buffer overflows left and right. And a buffer overflow to the untrained eye looks like a functional bug. The application crashes upon an input that's too long. But we in security know that's not a functional bug. That's a security bug. And actually next week I'm going to be at Hewlett-Packard office talking about buffer overflows and heap overflows and showing them demos and saying, this is what we want to make sure doesn't happen, because then, I insert my shell code and now I'm running with your permission level. So our team has to understand what those threats look like. They have to understand what insecure code looks like, and it's going to allow them to be more responsive. And also, and I'm preaching to the choir here, is we need to respond to security researchers who show up and say, I found this bug, without shooting them. Don't shoot them. Unfortunately, that's still happening a lot more often than we would like to think. One of my favorite security podcasts is Risky Business, and they mock the companies. This is still happening, where a security researcher shows up and says, I found a bug, and then they get a cease and desist letter sent to them, or even worse, maybe the police show up. So we have to be able to respond to security researchers without shooting the messenger, and whether that means having a bug bounty. Thank you. A bug. I swore I drank the coffee today. It hasn't reached my brain yet. A bug bounty system where we actually reward them for finding our problems for us. So we want to do that, if at all possible. At least don't shoot the messengers when bugs are found. So we actually had my company also does pen testing, and we had a client who was they drank the security Kool-Aid, which was fantastic. It was a lot of fun, and they were actually fixing security bugs as our team was finding them. This is so rare in our world. Usually it's we deliver the report, here are all the vulns we found, here are the criticality, here are the steps to reproduce them, and then 6 months later we come back and we just find all the same bugs again. They never fixed them. Actually, that's why I went into training. I'm trying to get ahead of that problem. But it's so frustrating. This team were like, yeah, when you find stuff, just tell Joe, and then he'll have one of his guys start fixing them. And that's exactly what was happening. Some of the bugs had less than an hour turnaround. They were, strong continuous integration team, and they were responsive. It was, I've seen it once. So I know it can happen. We can do this. It is possible. And it's just one of the frustrations of being in this environment is there are still developers out there who assume that our production environments are nice, happy, joyful places, and they're not. They look like this. There are tornadoes, and there are lightning strikes, and there are earthquakes, and Voldemort and Harry Potter are fighting, and this is what our production environment looks like. And so that's why a lot of these security problems are still happening, is even with all the news that is, now major media is, posting, Office of Personal Management just lost, 1 million fingerprints and things like that. Developers are still not getting the message, and it's whether, they are in an agile environment and management is just saying, well, we're going too fast. We don't have time for security. We don't have time to get better. But this is what's really happening, and that's why I'm sure you're here at the conference, and it's frustrating. I was one of the developer conferences I was at. We were having lunch and surprisingly talking about security at the table, and one of the developers told me, well, we don't worry about security at my company because only our customers use our website. It's like, well, good luck. Yeah, I'm sure that's what everyone thinks. Yeah, only our customers use our website. Yeah, and I'm sure only your friends come over to your house late at night and try to open your front door. So it's frustrating. So one of the ways that we can architect for security is centralized security components. We know security is important to us. How about writing centralized components? And I know there's a lot of developers out there who say, well, I want to do this because I can do it better than everyone else, and we all know those developers. But if we centralize components, say, like input validation, we know where our inputs are coming from. We know what good input looks like. That's called whitelisting. Maybe our inputs are complex and crazy. We can do that. How about writing just a centralized component that does our input? So if there is a bug, we fix it in one place, we test it in one place, and now we have less things to worry about. That's one of the ways we can increase the speed, keep that agility going. It increases confidence in our fixes. It's not going to show up 2 months later in another component down the road, hopefully. We're just doing it in one spot. There's a lot of other places we can do that. Authentication, authorization. One component, maybe a few developers work on that component. We don't have it widely spread around. Encryption, that's a big one. Make sure whoever your senior developers are who have had experience with encryption, they're the ones working on it. Not requiring every developer to add AES 256 capabilities to their components. Doing it one place. It's easy to get that wrong. I mean, even when so many websites they're using TLS and the configuration's wrong. They're trying to do the right thing, but it's not easy. There's no question about that. Key business logic too. If we can centralize it, if at all possible, it's going to make our life better. It's going to increase the speed in the long run because if there's a bug, we're going to fix it in one place. So it's not easy. There's no question about it. But there are things we can do to keep that speed up. Yet add security into each step as we go along without freaking out management. And when I'm teaching in front of classes, I try to relay that message is, business is important. We got to sell stuff. We got to keep our users happy. We got to find that balance between security and usability and security and performance. And it's important. If we go too far with security, everyone hates us like we're Windows Vista, and that's not good. Yet we got to protect our data too. And I don't want to be the developer that writes the cross-site scripting vulnerability that allows Grandma Betty's credentials to get stolen, and then now she doesn't have any more money left in her bank. So we know the developers who do that now. We know who writes every line of code. So I want to make sure that doesn't happen. So this is where I will leave you because lunch is at 11:55 and I show you 11:53. So thank you very much, everyone, for coming. I really appreciate you being here. And I'm going to step to the back of the room. I'm happy to answer any questions that you have.